So, two things: graph, T-chart style, and do the domain and range. Okay. When you're graphing, okay, it's important to use numbers that are compatible. Okay. So one thing we know about square roots is that we don't want to go into the imaginary territory. Okay. So first thing you want to do, turn this on. Restart. There we go. So first thing we want to do is make sure this is not negative. In other words, whatever's inside the radical has to be 0 or bigger. Okay. So, and this is your domain. Just keeping this 0 or positive. That's the domain. So we're actually going to start with the domain. Before doing the graphing, start with the domain. Whatever's on the inside. So over here, we're number 10. Now these are numbered funny because these are actual problems from the book. So you can check the back of the book on the odds. Those are, I just pulled them, gave you a graph so you can do all the problems. And then solve it. So you know that, oh, the domain here is x greater than or equals 0. So when you graph it, you should only have x values, right, x-axis, going this direction. You don't write this down yourself, but just imagine it. You know ahead of time what it looks like. Okay. Same thing over here. Solve it. So same domain. If I go down a little bit further, like here, on number 14, go all the way down on the left, we know, well, x minus 7. Okay, and we're doing this because we don't want a negative inside the square root. That's why I'm picking bigger than or equal to 0. And when you solve this, we know, add 7 to both sides. This domain is going to start here. So this graph, okay, is going to be over here and kind of go up or go down or something, but it's not going to be over here at all. So ahead of time, we already know what it looks like. Okay. What's the domain here on 17? Yeah, so on this one, -6. So we know on this one, graph's going to start way back here and open up or open down or something. By the way, is this going to open up? Is it going to go like this or like this? Okay. Which one? Okay. Take you back here. So remember, what controls whether it opens up or down? Yeah, positive, negative. Right? So what do you think? Is this opening up or opening down? Opening. Well, is this positive or negative? Up. Yeah. Remember the a value, it's the number in front of the square root. So if there's no number there, it's like a positive 1. Just like x by itself is positive 1x. So yeah, no number there. We know that this is going to open up. So you know a lot of stuff before you start doing all this picking numbers. I don't want you picking random x values and then saying, well, when I plug it in, I get undefined because I get imaginary, and it doesn't. You want to figure out, well, where should you start with your x values? So like here, I know, well, I should probably start with -6. Okay? That's where I should start. Start with the last possible point. Plug it in, see what you get. So when you plug in -6, what do you get? Yeah, -6 plus 6 is 0. Square root of 0 is 0. 0 minus 3, -3. So we know our first point is at 6, -3. And that's consistent of what we saw earlier. The number on the outside does what to the graph? Okay, if I look at it, yeah, if I make this -3, the whole graph drops down -3. So we expect that ahead of time. It's not going to be a surprise when, oh, that's what it looks like. We should have an idea ahead of time. Okay. Pick other numbers that are maybe a little bit nice, but you might need a calculator to get a decimal here. So don't hesitate to use a calculator to get some more values. Let's see here. What's another good number? -3. Why -3? Yeah, I'm thinking -2. Why -2? What am I considering? Yeah. When I plug it in, I want to have something I can take the square root of. So if I plug in -2, -2 plus 6 is 4. Square root of 4 is 2. 2 minus 3 is -1. So -2 comma -1. There we go. So we can already see it kind of opening up this way. So there is a method for picking nice compatible numbers. You won't be able to do that all the way through. You might have to pick, something, like 0, and find out on your calculator. Square root of 6 minus 3 is, whatever, 1 point. Why don't we do that just in case? Let's try that out. So what's square root of 6? 0 plus 6 is 6. Square root of 6 equals 2.44 minus 3. -0.5, and we'll round to the nearest tenth. So right about there. And we already know what the general shape is since it's a square root. It's going to look something like this. So you can kind of imagine it's going to keep going this way. And obviously, if something all of a sudden jumps way out here, you know you did something wrong. Don't just connect it and bring it back. Fix the mistake. It should be a nice smooth curve. Remember, this is just a parabola on its side. So it should be, just imagine this, tilting it 90 degrees. That's what it should look like. All right, and keep it going. All right. Let's see here. Anything else? Range? Okay. So here, what's the range on this one? Okay. Yeah. That number that makes it move up and down. Right, that k value on the outside of the square root, that really dictates the range. And if it's opening up, okay, you know it goes greater than. If it happens to be negative in front, you know the range will go less than. So all the graph is now below whatever value this is. So again, we know the range and the domain for actual graphing. Okay, I know that this is positive here, so it's opening up starting at -3. Okay, so we got y greater than equal to -3. And going back up to where we started, if there is no value, what is it? 0. Yeah, so this is the same as square root of 3x plus 0, so the range, this is positive, so it's greater than 0. If this was negative, that means it's opening down, then this would be less than. So this depends on the a value, positive or negative, plus or minus. Alright, let's look at one that actually has that. Here we go. Here's a good one. So what's the range here? Yeah, we know the number is 0, right? But is it greater than? And that's less than because this is opening down. What's the domain? Okay. X greater than, yeah. This still has to be positive inside the square root. So the domain has nothing to do with the direction of the graph. The domain only has to do with the fact that you can't have negatives inside a square root. Two entirely different values for different reasons. So you don't want to do the method for finding a range on the domain. You don't want to use the method for finding domain on the range. They're two entirely different processes. Anything on the back we need to look at? Let's flip that over. They'll get a little bit more interesting on the back.
Can we start to find the domain range?
Okay. So a little bit more going on. Number 18. Open up or open down?
Open up. No, down.
So what's the number in front of the radical?
Down.
It's like -1. So I could rewrite this. This is a +5. I could put that +5 over here, and now it's what they call standard form. It looks like everything else. Now I know my range is less than or equal to 5 because it's negative, and I know my domain is greater than or equal to -4. Okay. So don't let the numbers in different places fool you or change anything. It's whatever's right in front of the radical will let you know, does it open up, open down. Again, you will need your calculator. You will not be able to do all these nice numbers. You will need your calculator. Just do yourself a favor. Like the domain here is -4. You really need that number. Even though it doesn't say find domain, there's no place for domain, start off with this regardless, because this will let you know where your table starts. It's kind of like the vertex of a parabola. You have to know where that is to pick other points. And then when you pick this, don't pick -3, -2, -1, and 0 sequentially. Space it out. Pick -2, pick 0, pick 3, pick 7. So that way you get some better, actually it'll be going down here, you'll get some better, more accurate, okay, points. Okay. Look for nice numbers. Okay. If you plug in 5 at some point, that would be good, because 5 plus 4 is 9, and you can take the square root of 9. -3 plus 5 is 2. -3 plus 5 is 2. Yeah. So you can go ahead and graph it. 5, 2. Alright, so keep in mind there are some numbers that will work nice. Most of them will be decimals. Round to the nearest tenth as needed. Let's see here. Lastly, I think that's it. We do have some inequalities here. The only thing different here is the shading up, shading down, solid and dotted. Just recall about that. When you have a less than or greater than, then the graph will look like this. And less than, it'll just be shaded below. Okay. If it's like here, solid line, right, greater than, so when you graph that, it'll be solid line shaded above. Alright, good. Okay, let you guys work on that. Do remember, you guys just saw the schedule. Okay, this is due, you know, we'll say we have 5 minutes, since this is not brand new, but we'll have 5 minutes beginning of the period. Then we collect it. If you don't finish, there's no, let me turn in late, let me come back later. And if you see your grade just dwindle to something that's unpassable in 3 weeks because you're getting lazy, hopefully it doesn't happen, but you're setting yourself up. Well, I didn't want to do homework for a few days in May, and instead of being able to take summer school for 3 weeks, I have to do this again for a whole year. Try not to learn it the hard way and put yourself in that situation. Also, some of you guys have really good grades because you did really good on the quarterfinal. If you're kind of snoozing right now, don't be surprised if a bad grade on the last day of class drops your grade by 15%. If you don't know what you're doing, the final will show it. Don't want it to happen to you.